Right, so we've seen that we can convert ice to water by heating it up, and if we heat it up still further, we get steam. Now, we all know what temperature water boils at. Okay, so what temperature does water boil at? Want to shout it out? 100, yes, very good. So now, being true scientists, we should check this. We should do an experiment. So I shall take some water in my paper cup here, fill it up with water, and we're going to test to make sure that water boils at 100 degrees C. So I'm going to bring it round here, and we're going to heat it up. We'll check the temperature. There we are. So the temperature now is at 20 degrees. I'm going to heat it up with a Bunsen. Okay. Now, is this a sensible thing to do? A good experiment? Is this a good, well-designed experiment? Well, let's see. Okay. Now, interestingly, the paper cup is not burning. And this is because all of the energy from my Bunsen flame here is actually going into heating up the water. Now, the paper can't burn until it gets to a hot enough temperature, but the water is taking all the energy. So rather than heating the paper up at the moment, all the energy is going into heating up the water. So the water is now at 37 degrees C, 39. It's heating up. Well, we'll see what temperature this boils at. Actually, I think Chris can give me a hand with this, please. So, Chris, where is Chris? Here he comes. Perhaps you can just give me a hand heating up the water, please. Okay? Keep that there. Don't burn it. Thank you. Now, I have some water over here that we're actually heating up. This water, as you can see on the scale here, is boiling, and it's boiling at 100 degrees C. This water over here is only at, well, it's 85 at the moment. But we're going to see if we can make this boil at a temperature less than 100 degrees. While we're at it, I'm going to get my dinner on the go. So I'm going to have eggs, boiled eggs, I think. I need somebody to time this. Can I have someone, would you be able to time this for me, please? If you just start the stopwatch there when I say, just press the button. Okay, we're going to start the stopwatch when I put my eggs in. So we'll have one egg in the water here. We'll start this one first. This is in the water at 85. I'll just put the lid on. And we'll put one in the water here at 100. This water is already boiling. Okay, and actually the temperature here is it's dropped now to 77, 76 degrees C, and it's dropping, but the water is actually boiling. This water is boiling at 100. This water is boiling at, well, it's at 73 degrees C now, but it really is boiling. Now, why on earth is this water boiling at only 70 degrees, whereas normally we know that water boils at 100? Before I answer this one, I need to put the rest of my dinner on. I'm going to have egg and chips. So I need to heat up some oil. I need to get that on the go. Here's some oil. Mark, have you done me some chips? Where are the chips? There. Oh, there. Mark's done me one chip. Okay. I think he's trying to tell me something here. Okay, well, since he's only done one, I'm going to use a very small beaker. So we've got one down here already. I'm just going to put some oil in and get this heating. Oops. Okay, so just put the Bunsen on. There we are. Get that ready. Okay, I'm going to put a screen around it just to be safe. Okay, wouldn't want any accidents. Okay, perfect. Thank you. So that's the oil heating up. We'll come back to that later. Now then, back to this water. So water normally boils at 100. This water is boiling at 100, but this water is boiling at, well, it's at 71 degrees C. This is because, well, what we've done here, we put a lid on this, and we've taken some of the air away from this space here. So we've reduced the air pressure. And actually, we've reduced the air pressure to the same as it would be on the top of Mount Everest. Now, if you climbed up Mount Everest, you may know that you'd need to have oxygen gas if you wanted to do it safely, okay, as safely as you can do it. And this is because the air on the top of Mount Everest is very thin. There's less atmosphere there. It's actually about a third of the pressure as it is here in the lecture theatre. Now, why does this affect the boiling point? Well, I have some specially trained volunteers. They know who they are. If they can come down and get prepared, please. So we're trying to explain then why water normally boils at 100 degrees C at normal atmospheric pressure, but only 70 degrees on the top of Mount Everest. Right. Now then, so I need some water molecules, and they're over there, and some air molecules. These balls here represent air molecules, okay? And can I have my water molecules, please? Water, come this way. Okay, here come the specially trained water molecules, and you see they've got lots of energy, and they're bouncing around, as we've seen water does, and they've got quite a bit of energy, and they would like to get apart from each other, but the air is bashing them back. Okay, so the air bashes them back, and this means that only when they've got enough energy to overcome the air molecules bashing into them, can they boil and turn into gas. And that normally happens at atmospheric pressure at 100 degrees. But if there's less air around, and that's like we have on the top of Mount Everest, then they can boil, and they come out and they're boiling now, as you can see. They can escape, and this is because there's only a limited amount of air bashing them back. Okay, they can boil very easily. So as you see, they keep coming this way, don't they? Boiling until there's a little bit of air. So that's it, you see. The lower pressure means they can't fully boil. Thank you very much, water molecules. So, at the reduced air pressure on top of Mount Everest, water would only boil at 70 degrees C. This means you can't make a decent cup of tea on the top of Mount Everest, but also, well, can you cook an egg? That's the question, and this is what we're going to try and find out now. Okay? Can you boil an egg on the top of Mount Everest? Now, how are we doing for time? How long have we had so far? What's that? About 4 minutes, okay. We'll probably need a little bit longer for my hard-boiled egg to cook, so we'll leave that just a little bit longer.